6.4, the grade 9 applied math course, is an example related to direct variation still. It just looks a little different. And how it looks different is you can see if you look at, we're looking at a table of values for gas, and it's saying that, you know, it has sort of a random order of our liters and you know, the related costs. And so it doesn't jump up nicely. That's really all that's different. The other thing that's different with this particular question is the ugly numbers. So it's not nice, even numbers that we're dealing with, as life is not always nice and even, right? So we have a set of data, and the idea was to graph it. Now I've jumped ahead and done a lot of the work, and so while you write out your scale here, I'll explain to you some of my thinking, okay? First, how I chose volume of gas to be X and cost to be Y. The volume of gas is X because, first of all, it's left on the table of values, so then it's automatically X. But the other reason is that the X-axis is the independent axis, and if you think, that means that Y is dependent. And the cost is definitely dependent on the volume. So the cost would be the Y because it's dependent, and the X is the volume because it's independent. Okay, so here's my scale. Just let me explain it. Went up, basically just tried to spread out the space here on the x-axis. So I went up by every little line represents 2. And in the y-axis, if you did your own, you might have just chosen to go up by 1s or 2s or 4s or whatever, and you would have estimated a lot of your points, and that's totally okay. Totally okay. The graph still would have ended up looking fine. What I chose to do, though, to make the points nicer on the graph, was I looked at the data and I said my smallest point is 5.1, and my highest point was 20.4, and they're just basically multiples of each other. So I went up by 5.1s. So I put 5.1 here, and then 4 points later. So I started with just the blue, by the way. The purple I added later. So I went 5.1, and then this point is 10.2, right? So it went up by 5. Every single 4 spots is going up by that number. And then here I just sort of filled in the middle values. I did that just by hand afterwards. That's the purple, just so that I give myself better markers for finding good points. Okay, finding my points easier. And so this point, because obviously it's 0 down here, though I didn't write it, 0 right there. I chose 2.55 as halfway between, and this is halfway between. Halfway. That's all I did there. And again, you could do whatever you wanted. I was just trying to make up a scale that worked, and your scale may not be the same as mine in the future. For example, copy mine. So I'm going to plot out my data. I'm going to start with this one, I guess, down here. 6, it doesn't matter what order you plot them. The graph will come out the same. So I guess I'll start at the top, actually. So 10 and 8.5. So 2, 4, 6, 8, 10. I'm going to come up and find 8.5. So 7.65. It's going to be right around here, right? Almost right in between. Probably will fall right on that point. Okay. 16 and 13.6. So 16, I think that is a point that I have. No, it's not, unfortunately. But 12.75, and again, it's going to come right around in the middle. Again, there's a bit of estimating when you're dealing with decimals, and that's okay. The line will look fine. 6 and 5.1, so 6 is right here, 5.1, that one does fall right on a good grid. 24, which is 20, 24, 28, that's my 24, and 20.40, and 18, and this one does turn out 18 and 15.3, so 16, 18, and 15.3 right here. Okay? So this set of data isn't a nice you know, evenly spaced and all that. But as you can see, even if I'd done more estimating than I did, it still would look like a straight line. And you know from previous lessons that you can do line of best fit. Okay, so I'm going to draw my line. And again, the question: do I choose which of these? And my answer is going to be I'm going to choose the straight line, not the broken line, because I can, you know, this is sort of if you ever pump gas, you know, it's not going to fall right on 10 exactly. It'll fall somewhere in the middle. You can definitely buy parts of a liter of gas. So draw my line, make it, and you can see my points aren't perfect. As you can see, that one's not quite on, and you just do the best that you can. And I wouldn't expect yours to be perfect either. So does the data represent direct variation? Let me just write my answer to that right here. I'm copying and pasting is all. So my answer to part A, does it? DV? Yes. Straight line, and it goes through 0, 0. You can almost guess the next lesson based on what we're doing right now. All right, determine the, oh, I can't do that by type. Okay, so determine the rate of change. So rate of change is slope. And what does it represent? So I told you before, you don't have to choose any, it can be any 2 points you want it to be for a rate of change. So choose, I like to choose 2 that I know very well. So one of them, 0, 0. In direct variation, you should always choose the 0, 0 just because it's easy. I'm going to make these my 2 points where I do my rise and my run. So rise equals 5.1. And that just means it goes up to there, down to 0, and that rise is 5.1. The run for that same is 6. Okay, so rate of change, ROC, equals rise over run, equals 5.1, and that's dollars, right? It's cost per 6 liters of gas. So if you put that in your calculator and divide it, you get $0.85 or 85 cents per liter. And then it says, what does that represent? That's the cost per liter. That's what it represents. And this is what you would see. We wish we still had 85 cents a liter when you go to the gas station, right? That's what you see on the board. And this is obviously either written a long time ago or by a real optimist. We came up with the 85 cents per liter. So that's part B. C says write an equation. Now remember, we learned in the last video that the equation is of the form. The equation will be of the form y equals kx, right? Where y is whatever's on the y-axis, k is rate of change, and x is whatever's on the x-axis. So we'll say let C be cost, which is really our y, right? And let V be volume. That's our x, right? So our equation then is C equals rate of change, which we said was 0.85, times volume. There it is. That's our equation. And I think there's another part to the question which says use it to determine 25.8 liters of gas. So in part D then, V equals 25.8. Certainly you're going to need a calculator for this one. So C equals 0.585 times 25.8. Put it in your calculator. I can't do that one in my head for sure. 0.85 times 25.8, 29.93. So that's the cost if you bought 25.8 liters of gas. Okay, so I think that's the last example for this one. Looking ahead, here's the next assignment bit. So you go ahead and work away on that, and then that'll be it for today, and we'll start section 6.5 partial variation in your next video.